Okay, everything fine? Okay, perfect. So hello everybody to the repeat session for Discoverability to Chatbots, New Trends in Data Discovery. We are the Data Discovery Paradigms Interest Group with 4 co-chairs currently present, which would be myself, Ming-Fang Wu, Uwe Schindler, and Fotis. So, Fotis. Okay. Yes, and there's collaborative notes. I also posted them in the chat. Please enter your name. Since this is a repeat session, we have basically 2 different sections in the collaborative notes, and you can take a peek what the other people have discussed and what sort of comments they came up with, and also at your own at the appropriate position in the document. The session is being recorded, so please turn off your camera and microphone if you don't want to be recorded. Otherwise, please, this is interactive, hopefully, so please feel free to speak up at any point or raise your yellow hand, your virtual hand, and I hopefully will notice it. Since we have 4 co-chairs, you can also just write in the chat and interact with us in any way you feel comfortable with. All right, so what is the agenda today? We will start with a quick introduction of the group. This is what we are already doing. And then we will talk about one of the outcomes of this group, which is the 10 principles to improve data discovery. This is a paper that we have been writing for the last year, I think, and then we will ask you guys for discussion and feedback on these 10 principles. I would really like for you to try and participate as much as possible, so we have like a good discussion. We will also give you a sneak peek to the current draft of the document, where you can also make as many comments as you like, and please do comment. We are really relying on you guys to help us with this. Then there's going to be presentations on 2, I would say, rather new topics. And you probably all heard about ChatGPT and large language models. And so we have 2 talks that kind of tie into that. One of them is by Sarah Lafia from ICPSR about data chat prototyping, a conversational agent for dataset search and visualization. This is going to be a recorded talk, but we can try and answer some questions, or if you have more questions, then we can try to contact Sarah with these questions. And then there's going to be a second talk, which is going to be a live talk by Tianying Chen on a ChatGPT discovery study. So how can we discover data with ChatGPT, or should we even? And then we will have a quick discussion on that as well. And then we will have a wrap up and discuss some steps forward. Any questions so far? No? Okay. Let's proceed. So why do we even have a group on data discovery paradigms? What we're talking about here is the F in the FAIR principles. So metadata are registered or indexed in a searchable resource. Now, there is a little bit more to it than that. So we have this diagram about the research ecosystem. It's a very simple diagram, but the idea is that when you have a discovery system, there's lots of different players that are involved. You have, of course, the users. They have their own discovery context. There's a data catalog where all the data is in. You have data providers and curators, and you have also metadata records. And all these interplay in different ways. And one of the interests of this interest group is to figure out how to do this, and also on how to improve upon this system and on this problem. What are our objectives? First of all, we want to be a forum where like-minded individuals can share their issues on how to improve data discovery, their ideas, and also, well, sometimes we're talking about current research, sometimes we are talking about just projects that people are doing. So there's always something new. And as you just seen with the ChatGPT stuff, this is a fast-moving area, and it's always exciting to learn what other people are up to. And the second objective is to produce actionable recommendations for data producers, data repositories, data seekers, and data discovery service providers. We have made a lot of outputs already in this regard, and we are currently working on the one that addresses mostly data discovery service providers, but also a couple of other stakeholders, and that I will present later on. So you can see that we are quite active in both of these objectives. All right, so the interest group is, well, I would say as a computer scientist, it's almost prehistoric. So it's very old, 8 years. That's you know, twice the lifespan of a standard software project. And I believe in I wasn't there from the very beginning, so I'm basically just reading the slides here. In the beginning, there were 4 task forces about one of the guidelines to make data findable, use cases, prototyping tools, test collections, and metadata enrichment, relevancy ranking, and basically, I think the group is present in most of the plenaries, starting from plenary 8 and then on to plenary 9, where the draft of the task force output was discussed. And then in plenary 10, there was a couple of publications. One of them is 11 quick tips for finding research data, which is something which I actually cited before I even joined the group. So this is a very popular paper. Then, of course, also data discovery paradigms, user requirements, and recommendations for data discoveries. That's also a nice and highly cited publication, and a survey of current practices in data search services. Then in plenary 11, the 3 task forces were basically finished. There were guidelines for making data findable, the use cases, and also some work on relevance ranking. That was actually, yeah, so these are like the three outputs in a nutshell. I'm not sure if I should go through them in more detail. First of all, we have the 11 quick tips, which is really just something if you want to tell someone on how to search data efficiently, you just can give them this paper and it's still very valid and very helpful. And then the user requirements, the same thing. If you are looking for these recommendations, that has also been something that we've been looking at, but we are kind of like updating this one now. So I will talk about this later. And then, of course, the survey of the current practices. Since I've not been involved in this, if you have any questions about any of these, Ming-Fang and Fotis can probably answer them all. But I currently see no questions. So let's move on. Then there were 3 task forces, one on metadata enrichment for discovery, and one on data discovery and granularity, and one for schema.org for research data discovery. Now, personally, I was involved in the data discovery and granularity one where I also became the co-chair. This is when I started joining the group. And then in, I think it was around P13, there was a kickoff on the research metadata schemas working group. And then in P15, there was a user study on data discovery task force and the data granularity task force. And data granularity eventually got endorsed as a working group. Yeah, and then we started discussing on this 10 simple rules document that we will be presenting later on. And in P21, we presented an overview on the progress of the 10 simple rules and focused on the different challenges from across the communities. And yeah, P22, that's here. Like we're finally caught up in the present time. So what are the 10 principles? First of all, maybe we can post in the chat real quick the link to the document. So why did we even make what is essentially another version, or actually an updated version on it? We feel like a lot of things have been going on. The research landscape is the research data landscape is changing really quickly. We need we have how do you call it? We came together, we discussed it amongst ourselves, we presented 5 rules each on each of the plenaries and got a lot of super helpful feedback. So this is I would say a joint work of very many people. And the idea is really to go through the different topics or the different areas that can be addressed by data repositories on how to make their data better findable. So the document that you can see here is a pre-final version, and of course we can, we would like to encourage you to give additional feedback, ideally in suggest mode, because comments are kind of like difficult, because then we have to ask, is this really how you meant it, and so on and so forth. So please feel free to just, use suggest mode. And we are planning to submit this document as an RDA supporting output in mid-June. So you can see we are like very close to final. But still open to suggestions. If you have something where you go like, oh no, this needs to be added, then please go ahead. So, and these are the 10 principles. Principle 1 is that you should know your user. This is something that has been on our minds for a very long time. Because at least for one of my first interests was really like, how can we set up user studies for data discovery? How can we learn from existing user studies? And the recommendation here is to use a plethora of different techniques to find out what your user is all about. One of them is, of course, surveys. Surveys is basically you give users a questionnaire, ask them some questions about how they want to work with your system. Then you can also do interviews, ask people to use your system, and then do an interview about it, and interaction log analysis, which basically means that you have to set up some sort of system on to track what each individual user is doing, and then do some analysis on this. And then there's A/B testing, which is that you deploy 2 different versions of your system and then see which one has, like, how do they differ in terms of log analysis. Like if you, for example, have 2 different versions, like maybe in one version you use a different ranking algorithm than the other version, then you can track what the actual changes about that are. Like, are people more likely to find data? Are they less likely? And so on and so forth. And then there's also something that I've done quite extensively is observation. What we're doing is that we're sitting people down on their computers and we have a camera, or during Corona, what we mostly did was to just ask them to screen share. And then we just see how people interact with the system, with all the systems, and that is actually a very useful method to also see how your system fits in with the general infrastructure. Like, for example, like how do people even find your repository? And that leads me quite nicely to the second principle, which is about how to improve presence in web search. What we have found in our observation is that web search is actually quite important. It's a lot of researchers are using web search to sort of bridge the gap between, for example, literature, or they just heard about a data set somewhere on a conference or whatever, and then they're trying to find that. And there are a couple of steps that can be done to really improve your presence there. That doesn't only have to be, like when people hear this, they go like, oh, are you talking about SEO or search engine optimization? No, not really. There are some, more low-level things that can be done. For example, we can make sure that that users have a chance to find the repository on its own merit. And this is almost like the first step. So the first thing that you really have to think about is like, okay, if a person says like, okay, I'm looking for whatever your data is on the internet, and say like, okay, we are looking for a repository with this type of data, do they have a chance to actually find your repository? And this is, I think, the first step. Also something that people often do not really think about, because when you're doing a repository and you're working there full time, you kind of know where it is, and you kind of don't think about that someone out there might not know that. So this is basically just the first step of trying to put yourself in the shoes of someone who's just completely unaware of that you even exist. Then it's also very important, just as mentioned in the FAIR principles, that the content is indexed. So you might think, okay, I have a search index, so I'm good. But there's also all kinds of other indices. The web search has several big ones, like, for example, Google web search, but also Bing and so on. So you really have to make sure that the content is there. This happens a lot less than people tend to think. For example, Zenodo, for example, is actually doing a pretty good job in making sure all the content that you put on there is actually also appearing on web search, but it's not even perfect. Like they have several papers that you cannot actually find on Google because they're not indexed. So making some effort to make sure that as much of your content is actually also indexed in web searches goes a long way. And then, of course, you can, and this kind of goes hand in hand with the next recommendation, that you can apply low-level SEO measures to improve rankings. You can include keywords, strategic keywords, sometimes just simple stuff like data, and then embed machine-readable metadata like schema.org and a couple of other options. And then, of course, you want to be able to be harvestable to improve the number of indices that your data can be found in. And I just realized, like, I'm maybe spending too much time here. Like, photos, like, how much time was I supposed to spend, and how much time am I spending right now?
I think it's absolutely fine, because I did in the first round, I did like the overview of that, and then I redid the whole thing going through the document. So
Yeah,
ultimately, the same time we'll be spending both cases.
okay. So, the two first principles. Let's start right now here with the audience, get into a bit of interaction. So please, what do you think? What are your thoughts? Is it something that you're already doing? What do you think? So remember, there are 8 more principles coming up, so don't tell me like, oh, why aren't you talking about PIDs? Don't worry. So is there anyone who wants to chip in on this, say, oh, this is important, or maybe this is not important? Anything? Questions? Comments? So this was a lecture. I would just randomly call a name from my student, but it's not. Okay, I take that as a good sign. So let's go on. More principles. So another thing that research shows is that a lot of people are actually going via literature and user or research community. So this is another really important channel through which people get aware of the data. And there are a couple of things that you can do to improve that. One of them is, for example, that you provide downloadable data citation links. That people can just, copy and paste that, because this is still an ongoing problem that in many disciplines, data citation isn't actually widely used, unfortunately, which is a problem, and also why web search is maybe more relevant than it should be, because a lot of times people are looking in the literature, they're seeing a data set, but it's not the actual PID of the data set is not even given, although it might even exist. And then people will have to do a separate sort of research to actually find that. Then we need to link dataset metadata to publications and related research outputs. There are actually a couple of projects right now that are trying to do this. There's, of course, Crossref, but also Scholix and some some of you may have heard about the data citation graph that DataCite is putting together with some funding from the Chan Zuckerberg Foundation. So that there are some activities, and also my group is also working on automatically extracting metadata citations and mentions. That's something that can be done, and I do know that some repositories just have information on this, but they don't show it because they go like, oh well, who's interested in this? But for users, this is actually like super relevant information, both ways, by the way. Like if you have the publication, then linking to the data set is super helpful, and if you have the data set linking to the publication, is almost as crucial. Then our third recommendation is that you should engage in the research communities proactively. This is like almost like the standard you need to do marketing thing, and this is something that a lot of repositories actually do a lot. Go to events, have their own little table, distribute merchandising sort of thing. But also just inform people about what kind of data they can find there. Then the fourth principle is that you should support both disciplinary and interdisciplinary research. This really depends on what kind of repository you have to begin with. Most repositories have some sort of intended user community. I don't know, archaeologists or whatever. And it's kind of important to identify who you're targeting, and then also to try to engage with the community directly. But also, you will always, increasingly people are trying to look over the boundaries of their own data set or their own community to find data sets that might be relevant. In social science, for example, we have a lot of people who work now with Twitter data, and so on and so forth. So it's really important that you try to keep your data approachable, even from people from the outside. And what's also important is that we try not to think too much in this disciplinary boundaries, because in fact many disciplines they have all these gray zones where things overlap. Improving metadata interoperability and reusability is key to this. We all know that there's like the core standards, DataCite or Dublin Core or whatever you're looking for, DCAT. But there's also the issue of if I have, for example, a neighboring discipline, maybe I can see if I can, make my metadata available in their standards as well. And then another thing that's important is to allow people to use search terms from their discipline, but also from other disciplines. This is, for example, interesting in data that is, for example, relevant for both biologists and people from the medical community, but also in a lot of other cases where you just, you have different ways to describe the same thing. Chemistry is also an example. Yeah, then we had this idea of that you want to provide multiple data search entries, again, depending on what kind of perspective you're looking for, and of course, provide and support machine readable metadata. I think this is like one of the topics that kind of runs through the 10 principles a little bit, is that in order to do good stuff for users, you also have to be open to machine readability, because most of the machine readability at the end also feeds into stuff that benefits your users. Right, and then we have fifth principle: support data search from broad terms to narrow terms. We need to enrich the content to annotate broad terms and narrow terms. This is also something to do with the interdisciplinary thing, because we cannot expect people from another discipline to be as familiar with the technical terms. And then we also should be aware that we need to enhance data search functionality. So these things are actually important. these are actually workable. So it doesn't, you know, just enriching the metadata just only helps you to a certain degree. You also need to increase the functionality to actually leverage all this wonderful new metadata that you have. Right. Any questions on this? Because I need a quick water break. Or comments. Or, okay, so I feel like you're all probably, okay, Graham, thank you.
Yeah. So P4R2, what do you mean by dataset beholding? It doesn't make sense to me. But the sentence doesn't make sense. Could you expand it a bit more, please?
Okay, anyone want to chip it? Because I was not, the P4 is not my specialty.
Graham, so yeah, it's a good question. So I suggest to change that in catalog the data set. Basically, you don't have, if you're trying to support interdisciplinary search, you just don't have a data set for one discipline. You should increase the coverage of disciplinaries in the data set you catalog.
Okay. Okay. All right. Thanks.
Yeah, Graham, you also had the other statement that there should be some guidance about data availability statements. I also agree with that. I posted a link there. There's a paper already available, how the data availability statements of journals should look like. So although this paper is more focused on journal production, so the publishers, but in general is also interesting for users. But maybe we should put a link into the document.
That sounds like a very, very good suggestion. Okay. Yeah, I trust you guys are monitoring the chat, because I just see that the number is going up and I don't really have the time to just look at everything. Okay, then let's move on to more principles. Principle number 6, we need to manage the duplication of metadata records, or rather deduplication. Now, everybody who has been working at least a little bit in harvesting, you quickly realize that there's all kinds of multiple different versions. And one thing that's kind of important is that we need to know why duplication occurs in the first place. This is something that we really learned. And then also that we should try not to give out different DOIs for what is basically the same DO, the same digital object. Or if that happens accidentally, that we really try to link to primary DOI, because a lot of things, you know, like, I don't know, data citation counts or whatever, it just doesn't work if you have the same object under multiple different names. Yeah. One of the sources for duplication is versioning, that people just put different versions of the same data in. So you have this like duplication that kind of makes sense because it is another thing, but also it's very, very similar. And that poses a lot of different problems, because for the user, first of all, like okay, let's take an example from my domain, social science. We have the survey, which basically runs every single year for the last 20 years. And then there's like slightly different versions of it. And so when you just enter the name of the study that does that, you get 300 hits, and it's all just from that same study. And that is actually not very nice for the user, because they were looking for this data set. They were not looking for, you know, the auxiliary study that was also done in 2015 that also, you know, just a subset of the original data set. So what is really important is that you try to keep all these different versions together in some way. I know this is not always easy, but I think it's really worthwhile endeavor to improve usability. And what we are doing, and what I think should be done, is that we utilize technology to identify and manage the duplicates, and then try to get them together without No, what I mean is that that there will be obviously duplicates that will happen even though they have different DOIs, and that it really pays off to identify these and to somehow subsume them in your user interface, because otherwise you really quickly run into these problems that people are looking for one thing, what they're getting is 300 things, and that doesn't sound too bad unless you realize that there might be maybe 5 other things, 5 other studies that might also be a valid search results, and those can't be seen at all anymore because they're just drowning in that, huge sea of duplications. Right. So next one is provide and link metadata at different granular levels. This is also something that kind of ties in with the last thing, because one of the reasons that there can be a proliferation for duplication, I mean, it really depends on your domain. There's all kinds of different reasons as to why this duplication happens, is that people publish data sets on basically the same thing, but from different granularity levels and with different subsets, which may make sense even, but of course you kind of have to manage this and try to keep them together. So one thing that I think is important there is to have the data set at different granular levels, and to use structural metadata to link resources at different granular levels. So the idea that a data set, like if you want to really make people able and capable of finding things that are within your data, you really need to pay attention to what the subsets of the data sets are, what the variables are, what the different parts of the data are, and to try to capture that in the metadata. And then also to make sure that you link these things together and that you keep them together, because otherwise you end up in the same problem that we had before, that you have like this, that you're drowning the user in things on a certain granularity level, and so that they can't really find the thing that they're actually looking for. So this is one of the problems that we have with, okay, we want to have surveys, right? But we also want people to enable to find questions within the surveys. But the second that you allow that, immediately all they find is questions, because obviously there are so many more questions than surveys out there, naturally, that the surveys themselves, which are in many cases the thing that people are actually looking for, kind of drown in the lower granularity level. And for this, we really need flexible data search interfaces. In literature, we're really in the fortunate situation that a book is, I mean, it's variable in a certain way, but it has, like, there's certain boundaries as to how short or long a book is, or even if you have like an abstract, it's all more or less the same. Like if we're talking about a paper, we kind of know what kind of order of magnitude that is. But when we're talking about data, things that get labeled with the PID as data can be as small as 1 data point or as big as a complete climate model, right? And so you kind of have to find ways to navigate between those two things to be able to say, like, okay, I'm looking for only things from this region, and so on and so forth, and to be a bit more flexible and more fine-grained than just saying like, oh, okay, here's this one option, like basically this one window where you can just type in a word and then we will get you the object that you're looking for. I haven't seen an interface like that would actually work. I'm not saying it doesn't exist, but I haven't seen it. Right. And then what we also need to do is consider users' metadata needs, and also they really go to a user perspective. This ties in with the principle that we had in the beginning, that we need to do user studies, that we need to find out what are the needs. And then, of course, we need to balance between generalist repositories and disciplinary repositories. Disciplinary repositories have many advantages. For example, they have a certain homogeneity. For example, we are mostly doing surveys, so a lot of things can be simple. But if you're too focused on something, then you're kind of like hiding other information from your users that might be relevant to them. So there has to be some sort of balance between these two approaches. And then another thing is that we need to involve the users in metadata enrichment and to improve metadata quality. First of all, because metadata enrichment just for metadata enrichment's sake, it's a nice research paper, but it's not really bringing you forward in terms of data discovery. And also, users are often very, very strongly involved in these sorts of things. And if you try to tell them, like, what are you looking for, what can be done, and they're actually often highly motivated to help you. And then last but not least, AI technology, which is also something that we talk about. There's lots of algorithms out there that can take text and make more information out of it, produce structured information. The difficulty on using these technologies has become lower and lower, so you don't need to hire like a super expert anymore. You can just basically go with a student who types in a couple of prompts in ChatGPT. And that already helps you a lot to turn your unstructured textual data, if you have any, into a nice structured data that you can put into the database. Obviously, AIs make mistakes, but always keep in mind that humans also make mistakes, and that's no reason not to use humans, right? Okay, any questions or comments on this? Okay, then I will.
Sorry, Bridget, maybe for Graham to clarify, is that question Graham asked augment dataset cross-discipline through catalog? So we're talking about augmented metadata. So for example, when a repository or catalog get a metadata record from another repository, they may add more metadata. In that case, maybe, a suggestion is to be that metadata record to be versioned. Does that answer your question?
Yeah, I was just suggesting kind of alternate wording, that's all.
Okay.
So I think it's the same thing. It's basically, I think you were saying earlier on that you can increase the data set's discoverability through the cataloging by increasing its disciplinarity. I was just suggesting kind of slightly different wording, that's all. So you can augment a data set's cross-disciplinarity discoverability, I suppose is the missing word, through the cataloging. So as in, you got your cataloging, yes, that kind of comes primarily from your metadata you get from your data set, as it were, but you can then bolt on extra things to then say, actually, it might be useful in this area or this area. For example, if you want to say, I have a data set, but actually, you could use it in machine learning, for example, or this other way by just adding a different set of keywords onto it.
Good. Thanks for the.
Yeah. Okay, so let's move on to the last and second to last. Improve metadata quality. Metadata quality is like a big issue for every archive, I would say. What we need is to do that we select a schema and also use standard vocabularies that enable the description of data properties users need. This also ties in, of course, with the user studies, so you need to know what people are using. Then the metadata record should be accurate to reflect the data set and strive to be as complete as the schema allows. This is also an important thing. I have been trying to mine DataCite metadata, and I found that it's in many cases, repositories actually just deliver a subset of what they actually know to DataCite, which I mean, like from a practical standpoint, it's actually very understandable, because then everything becomes a lot easier. But of course, it means that if you are trying to find the data via DataCite, you are robbed of all the additional information that you would have otherwise. So that's an important issue. And then there are a lot of validation tools. So another thing that I discovered when we were doing lots of harvesting is that people are, for example, using schema.org, but then they have a syntax error in the schema.org, and so it's not actually automatically readable. It's just almost automatically readable, and it's been on the website for years and nobody has ever noticed. So there are validation tools to detect syntax errors or other errors, and doing, like external reviews or to check am I being harvested correctly goes a long way. There's also all kinds of fairness evaluation tools or assessment tools that can give you an idea about the fairness. That also ties in with metadata quality, although of course most of the time they don't actually look that deeply into the metadata, but that also gives you an idea of how accessible your metadata is and how much it works with the expectations that people generally have. And again, apply machine learning for metadata extraction. This is also something that we come back to, is that there is quite a good technology available to have all these different kinds of to enrich the data discovery process. Now, last but not least, enable linked data. This brings me to the PIDs I was alluding to earlier. We can allocate min PIDs in the metadata. That is basically the prerequisite that it can be linked in the first place. And then, of course, we should reference existing PIDs or URIs of other people's data, but also of other things like ORCIDs and RAWs and whatnot. And that immediately makes you part of a huge network, and that also allows people to discover your data more easily. Okay, so I see that the numbers in the chat have pinged up. Anything that I should take note of? Or any questions on the last two principles? Okay, I don't see anything. Let's come to this slide then. Obviously, not all of these principles apply to everyone in the same way. And so what we did was we try to, give a bit of guidance as to who these principles are for, right? So what kind of topics do they cover? And this is why we came up with this chart. To help people navigate a little bit, like, okay, what's relevant for me and what's not. Basically, we identified 4 different roles, and then try to pinpoint what is relevant and what is not relevant. Maybe you can have a quick look. I'm not point out every single cross, because that would be silly. You can all read. But again, this is something that we added quite recently, so we would actually be like super eager to have feedback on this particular thing, because this is really something that we came up with quite recently. And if you'd have any comment on that, where you go like, okay, I don't understand this or something, then please go ahead and share your thoughts. Okay, I don't see any comments. So I'll just take that as non-controversial. Okay, let's move on. Yes, any other questions and comments? But I have, done please enter your questions and comments now so many times that I think we can skip that. Right, so let's come to the technically challenging part, which is that I'm supposed to start the presentation. Oh, there we go.
Great, thank you so much. This is exciting. I'm
Can you hear that?
Sarah Lafia. I'm currently a research methodologist at NORC here in Chicago, and I was formerly a postdoc at the University of Michigan at ICPSR, where I did this work in collaboration with Leo Fan and Ling Yao Li, Fan Yang Wang, and Libby Hemphill from University of Michigan School of Information. So I'm presenting on behalf of our team, but really excited to add this maybe as a use case, illustrating some of the principles that you just presented. So also looking forward to a bit of a discussion as well. Great, so the motivation for this work is really in two parts. So thinking about how we can think, what types of technology we can leverage to help users overcome barriers that they encounter as they search for data. And so this research is really situated in the social science space, so thinking about the types of considerations that users have as they evaluate research data, specifically at ICPSR, but also what types of information or knowledge they need to make decisions about data use. So a few points to raise here. The first being that users really need, we know from prior work, such as that of Jeremy York in 2022, that users need to understand the context of data in order to properly reuse it, and also even before using data to understand the relevance of data to their particular use case. And in addition, we know that this problem that you were just introducing, this idea of disciplinarity. So users outside of knowledge communities tend to sometimes lack expertise in order to properly find and repurpose data. And so thinking about these two sets of challenges, we wanted to think about some types of search interfaces and paradigms that we could introduce to help offer a way for users to overcome these barriers. So some of the design goals we can split into front-end interactions and back-end relationships in order to achieve these different objectives. So on the front end, we were thinking about what's currently possible, at least at ICPSR. It's there are quite a few ways or entry points into data, and so we build off of those. And the goal here is also to help users of the system increase their proficiency and also understand what's happening with search on the front end. So to do this, some of the front end interactions we considered involved allowing users to ask questions in a more natural language way, and also present some of the information or the relationships between data on the back end in a network. So using techniques like network visualization to help explain the relationships between archived studies as well as related literature. And then to enable this on the back end, we were thinking about ways to, we have these rich relationships that we can represent in semantic triples. And so on the back end, we build off of this, this metadata context by exposing links between entities. And here the entities really that we focus on are the data sets themselves as well as related literature. There are a number of other entities that are interesting to consider, such as the authors themselves, but we'll get into that in a bit. So the current state of search at ICPSR, as I mentioned, is quite rich. This is an example of one way you can find data. There's keyword search here in this, you can enter search phrases and keywords or topics of interest. And there are also a number of facets you can explore on the left that can help you narrow down the universe that you're considering. In addition, ICPSR offers in addition to indexing studies, there are also indexed variables, over 6 million, which is quite overwhelming. Data in series, so these repeating and linked studies that can be explored over time. Data-related publications, which is a vast bibliography of dissertations, as well as other types of peer-reviewed articles and gray literature that have been that have used ICPSR data. And then you can also search the website. But the idea here is to build off of the relationships that are stored in each of these facets and really help pull together and allow users to search against the relationships between, for example, studies and publications, in addition to searching in this traditional way. So here we have a number of linked resources that are exposed individually, but they're not, rather the relationships between the items are not apparent to the user. And so the idea is to help make those relationships, which are implicit, explicit, and visible. So in this new way that we enable search on the same underlying database is to allow users to search as they would with exploratory keywords or known study names. So the actual search that's being issued is not so different, but the relationships that they're querying against are more explicit. So that's the front end. And then if we think about what's happening on the back end, we really, in order to make those relationships explicit, we turn to knowledge graphs as a way of encoding the relationships that we wanted users to be able to explore. So in essence, knowledge graphs really allow us to formally encode relationships between entities using different types of properties. And this is just a plain example of different types of statements one could make about the entity, the Mona Lisa. You can also associate other entities like Alice, the person who has a birth date, and etc. So we can build out these rich triples that we can then ask and answer questions about, such as who is interested in paintings by Leonardo da Vinci. We have the entity, which is the painting, and then we have the entity of Alice. And so we can traverse this graph and find that relationship. So adapting this to our use case, we build off of work in the area of scholarly knowledge graphs, which really strives to, much as this group is doing, build out linked data relating different types of scholarly entities, such as publications, authors, and additional properties of those, such as topics, affiliations, institutions. So we build on this scheme in our work. So the schema that we work with here is really, really centered on the data sets themselves. And then we associate a number of different attributes to those data sets that can be queried. So the core here is the data set, which has unique ID, a date, and then some usage information. This is important because one of the types of or competency questions we envisioned the user being able to ask revolves around usage. And while ICPSR does make this type of information explicit at the study level, it's quite difficult actually to query against the usage information. So by encoding it with the data set, we make it a bit easier for the users to query those the usage information directly. We also link the data sets, which are already linked to publications, but in the interface, we make those relationships between publications and data sets more apparent. And what's great about this is that many publications use more than one study or data set from ICPSR. And so when we view the data sets in isolation, we are not able to understand, or it takes more work to really understand what types of co-citation is happening or what sets of studies, or multiple studies get used together often. So we make that relationship a bit more obvious as well. And then we have a number of other properties that are associated with the data sets, such as the owner or the funder, for example, the National Institutes of Health. If it's part of a series, what the series name is, some geographic information such as locations, and then terms. And I would add, none of these properties are new. We're just pulling them from the studies themselves, but making them explicit in the interface. So pulling all these components together, on the back end, we have a graph database, Neo4j. That's a prototype that supports or stores all of these triples. And to create the triples, we ingest the two sources, ICPSR's metadata catalog, for all of the study level information, and then ICPSR's bibliography of data-related literature that has explicit relationships between studies and peer-reviewed articles, dissertations, and other types of materials. So these triples are stored in this Neo4j triple store, and rather than expecting a user to learn how to interact with the triple store, we came up with a solution to essentially host the triple store or expose it through Streamlit, but also leverage the OpenAI API in order to translate the user's query into the language that the triple store uses, which is Cypher. And so this process actually allows users to issue natural language questions to the triple store, and then the service will translate their query into the query for the triple store and return an output in an interactive interface. So really what this is doing is from the user's perspective, there's not much happening, but there's quite a bit of translation happening on the back end. So just wanted to note that that's how we're using OpenAI in this setting. And then a quick note on the use of GPT, again, reinforcing the idea that we're here in this prototype, we are using GPT essentially to translate users' queries into operations on the graph database. And we really did this because we didn't, it seemed like a flexible way that would allow us to allow the user to interface with the graph database, but not have to actually write Cypher queries. So this is an example of the type of syntax that would be produced. So if you wanted, for example, to ask questions about the actor Tom Hanks and who has acted in movies with him, you could just ask this as a natural language question, and then on the back end, this type of process would occur where there's this question is translated into a Cypher query issued against the triple store, and then an answer is returned. So again, because also we're working in we just wanted to emphasize that no user or content information is actually exchanged with OpenAI servers, but rather we're sending user questions to the service in order to get the syntax back. So
I don't think it's playing something. Oh, there it is. Sorry.
Yeah, so that is the video inside the video, and I think the sound doesn't work, and she's going to notice it in a second.
is there audio, or should I?
There we go.
Okay. So this is just showing that my colleague is explaining in the video as well. I can put the link in after, but essentially it's showing the two ways you can interact with the interface. So here he's asked, what are the latest data sets owned by ICPSR? And it will show the Cypher statements. So you can iterate on the query to make sure that you're getting the result that you want. And you can also then, when you have a result that you that is satisfactory, you can also visualize it in the chat interface. There's a little bit of interactivity as well with tooltips, so you can see a bit more context from the search results. So here in the question about the most current data sets that have been published by ICPSR, these 3 data sets are returned, and you can also see a number of different attributes or properties about them. So just a quick walkthrough. This first interface is allows you to talk with a data chatbot, and so you can pose natural language questions to it. For here in this example, the user's asking about the latest data sets about health that have been cited by publications more than 3 times, and so the service returns a Cypher query as well as a number of search results. And so the user can get us and begin to develop an intuition for what properties are being included in the query, but at the same time could also ignore this part of the response. But here, this type of question builds on this linked data by asking about usage information alongside the relationships between the publications and the data sets. So I think this is quite nice because often users want to, especially during data exploration, want to try to ask different types of questions and also probe the system. And so this type of iteration or conversational style with a system can be very helpful for that initial pass and trying to better understand what types of properties are exposed and what types of relationships are available. The second piece of this then are these interactive graphs. So there's a chat visualization. So it's possible in the interaction with the system to also visualize the relationships that you're asking about. So in this case, these 3 data sets were returned in the search results, but also we can see that in this example, these 2 data sets have the same owner, so that might be interesting to explore. And in this case, also these 2 data sets share the same funder in common and a number of search terms. So this might indicate that, for example, there are a number of recent studies ICPSR has published related to health that that are probably the result of additional funding sources coming in from the health domain. So not only is this important or helpful for researchers themselves, but we envision this type of interface being helpful as well for repository managers and possibly for other types of users such as funders or other stakeholders who frequently search usage information alongside data sets. So thank you so much for the opportunity to share this work with us. My colleague Leo is the lead author, and I've included his email address here. And we have included, I'll put in the chat, a link to the demo, again, with the volume, so you can hear his explanation. And we've also published this short paper at ASIS this past year. And so if you would like more details on the system, I'll refer you to that as well. Thank you.
All right, now I have to somehow, here we go. I will just stop sharing. I'm tempted to say any questions. Maybe we can answer your questions, but not necessarily. But anyway, is a bit of discussion about this? Is there anyone else who has, like, any other people experimenting with this sort of systems? I'm always really eager to hear about these things. Okay, so this is still fairly new. Okay, and then I would say we move on to the next talk by Tiangying. Are you there? Are you sharing your screen?
Yes, give me 1 second. Okay, share my screen. Okay, so should be working now, I hope.
It's not full screen, but I can see it. Yeah, now it's perfect. Thank you.
Okay, cool. So yeah, thank you everyone for the opportunity. And today we'll be talking about our present ongoing project about leveraging LLM for data discovery. So please keep in mind, this is still an ongoing study. So I'm just presenting mostly about like some preliminary results, and we are still recruiting for more users. So none of it is definitive, and it could definitely change. So just please keep it in mind. So to get started, as everybody probably already has seen that with the rise of ChatGPT, that LLMs are basically being used for a variety of purposes, and especially as a search engine. So for example, in this study, by Ayub in 2023, the users basically used LLM as a tool for patient education, basically asking them to search about general medical information, and had shown that it's basically more or less as good as the traditional search engines as Google. And also at the same time, another study by Murgia used ChatGPT in a classroom setting to teach students about historical events. However, it showed that the LLM was promising, but it sometimes provided potentially inaccurate responses. And lastly, in this study, the users used the ChatGPT as a search engine for users to compare different products when they are purchasing online to see whether the search results provided by ChatGPT and how do they compare to the traditional search engines. So of course, this goes to a topic that's more interesting for us, which is how does LLM actually look in the scientific research and how does it perform in this context? So of course, LLM has also been increasingly used in scientific research and writing. As you can see in this graph, the users showed with the release of ChatGPT, more and more research papers have actually had more AI-generated content. So these graphs basically show the average score of all the published papers after the release of ChatGPT and how much AI-like they are. So of course, this trend is not really reversible. So the best thing we can do is to understand how we can actually best make use of LLM and make use of its variety of abilities and having the caveats in mind. So that shows our research question to be, since LLM in research is unavoidable, how do we actually best to use it for data discovery? So in order to answer this question, we came up with two research questions, which is, first of all, what is the difference between the accuracy, relevance, and efficiency of search results obtained using LLM and traditional search engines? And also at the same time about the users, which is how the user experience different on each platform for dataset discovery. Because of course, the users are the people who are using it. And aside from understanding what the LLM can actually do, it is also important to understand the interaction because between the people who use it and the LLMs. So to answer these questions, we use the mixed methods study with qualitative and quantitative parts with 30 participants. So this study is still ongoing, as I said, and I'll just be presenting some of the potential preliminary findings that we've found. So the criteria for the users were the users had to have some experience with dataset search. So the procedure of the study was the users were first asked to fill out a demographic questionnaire, and they were asked to engage in a search task for 15 minutes. So in these 15 minutes, they will be asked to search for a data set to answer a research question using whatever method they usually use. So the question, for example, can be, how did the loudness of music change over 1950 to 2000? So they're asked to basically find a data set online that they can analyze in order to answer this question. Then they were asked to fill an assessment about their experience, which I'll explain a little bit later. And then they will engage in search task 2, which is the same, whereas this time they're asked to use Microsoft Copilot for the same task. And then we asked them to do a think aloud throughout this process, narrating their thought, and also observe their behavior throughout this process. And then lastly, they are asked to fill out the assessment again. And in the end, we have an interview about their whole experience. As you can see on the bottom here, that's the qualitative part that we try to understand the user's experience. And on the right side, you see the quantitative part that we assess basically the quality of the search results and their subjective perception of the process. So in terms of the quantitative assessment, there are 4 measures that we have found in the literature in order to use for this process. So the first is the trust in the quality of results obtained with an example question such as the results provided by this search are extremely dependable. And also the cognitive load, such as how mentally demanding was the task, perceived usefulness, such as using this tool would make it easier to search for data sets. And then lastly, perceived ease of use, such as I would find this tool easy to use to search for data sets. So basically, these are all answered on a 7-point or 21-point scale. And for the interview and observation, we aim to answer the question of what is the procedure that users take for dataset search? What considerations do they have when they're using different platforms? And also, what are the challenges and benefits of using either platform? So, and now I will talk about a little bit of the preliminary findings that we found in the 6 participants. Even though we have a very few participants right now and the study is ongoing, there are some interesting themes that we have observed that we believe can also be further, it would become more elaborate when we have more participants. So first of all, what we found was that the expertise potentially impacts participants' trust in AI-generated results. As you can see, one participant said, I'm not an expert on this topic, so I feel AI gives me some directions when I'm looking for data sets. However, with another more experienced user who was a postdoc and has more experience doing these searches, they said the results generated by AI are not very high quality because the data sets don't really contain the metrics or enough metadata I need to answer the questions. So at the same time, we also found that LLM could be helpful in the right role. So what that means is, for example, in this case, the participant 6 said, I think the results generated by LLM could be a good starting point, especially if I don't know what I'm looking for. However, you frame the question seems to give you the same 3 answers, so it's not enough. So a lot of participants basically expressed the thought of like, they really think that the AI provided result could actually be a good starting point for them to keep going. However, because a lot of times the results seem to be a lot more limited, so it doesn't really make sense for them to rely on this result to be just purely just to be everything instead of just using it as part of their search and for them to further explore on this topic. So in terms of the limitation, obviously for this study, we are doing it in a controlled manner with 15 minutes for the participants to conduct their search task. So it might be slightly different from how they usually would conduct the dataset search. So in order to address that, we also are planning on a follow-up diary study for the users in order to ask them to use the AI-based tools in their daily work in order to understand, would it be different if they actually implement these tools in their daily usage, and how is that process, how is that process really in real life, basically. So that concludes the talk, and thank you everyone for tuning in, and please feel free to ask questions.
Yes. Any questions about this particular study? No questions. I don't know. So have any of you ever tried to use ChatGPT or Copilot to find a data set? You should, because it's actually kind of good. So Mingfang, what's your question?
Not to your question, but a question for Tian. Excuse me. So the variation here you try to compare is one with normal search engine, one is with LM in the loop. Is that right?
Yeah. Yes, yes.
Yeah. Can you explore like is there any other variables here, like task variables? What task be better, you know, to use a search engine? What kind of task better to use the one with LM?
Yeah, I think that's definitely a very interesting question, and that's probably something we'll look to explore next. Basically, what kind of tasks might be different. So kind of the focus for this study is more about like the user experience, and kind of because right now we don't really understand, you know, how do people even search for the data, and then basically how do they feel about the process. So it's kind of like, you know, the focus is like we want to understand, you know, what it is and then basically how it works, before going to exploring kind of like maybe, oh, how do we actually format the prompts, and how do we actually, what are some topics that are actually good? Because, I think by understanding how people work with AI, that can also tell us, for example, when we're designing specific engines for dataset search, how we actually can design it and how we actually make sure the users understand what they're doing. So things like that. So I think that's a great question, and I think that's definitely on our radar to explore next.
Thank you.
So we have another question in the chat, which is, how do you deal with hallucinations?
So yes, thank you for that question. So that is also so basically how we evaluate kind of like the results so we're not evaluating kind of like the results generated by the AI, but it's more of like how the users use the AI. So for example, if they does have hallucinations and things like that, it's the user's task basically to figure out, okay, this is not a real data set, because in the end, we want them to find us the actual data set. So we also basically look at, what they found in the end. So if they use ChatGPT, we're like, okay, can you give us the link to this database you are going to use? So, by doing that, it's basically the user's task to distinguish, whether something is good or bad, and then give the final result of like, oh, this is the database that we found to answer that question. And then we basically evaluate that instead of the AI itself.
Yeah, so the question is really like how, but how do they? I mean, how do they do that? Like, is that a huge problem? Do they believe hallucinations?
Actually, not really, because I think maybe with GPT-4 or something, this problem, is slightly better, because every time, for example, when you ask for the data set in the Copilot, it always gave you the reference, so you can just click on the link that it provides and you can go into it and see whether the database actually exists. Sometimes it gives you the site and it's like a little bit harder to find it, but I think in our experience of observing, like that actually has not been as big of a problem as you would have imagined.
Okay, so that's good to know that we're not, going to start using hallucinated data sets in the future, because that will be weird. Okay, any more questions?
I never used the GPT to discover data set, but I just send a query, find data set that has average rainfall of Melbourne. So it's point me to Bureau of Meteorology of Australia for the data set. Well, a good start.
Yeah, I have to admit, I did this so once I had the idea to do this, I actually did it with and also for the tasks we did like a couple of those. It was super interesting. One of the motivations was actually that I stumbled upon a data set that I could not find with web search, but I could find it with ChatGPT, and I was like, oh, okay, this is interesting. So how did that happen? Obviously I have to assume that they use the academic web extensively for training the large language model. So the large language model actually knows a lot about data right off the top. So that's quite interesting. And since it also reads the whole description, it actually knows a lot about the data set as well. But as Veronica pointed out, sometimes it just makes up data if you are pushing it too far. All right. Like in principle, we have 10 more minutes. I will share my slides again to go to the final closing. So that should be, yeah. Okay, so if you found this even remotely interesting, please join the group. We're meeting virtually on every third Wednesday each month at 12 p.m. UTC. There should be a virtual reminder sent out, but as Nick has pointed out, this apparently doesn't always work. If that is the case, please send us an email, and then we will try to fix this. I think we've all experienced one or two hiccups with this new website, so bear with us. It's not our fault. Yes. I don't recall where we have the slide. This is really old. Like this was like one of the outputs that we were supposed to do, like in plenary 9. All the different task forces that we're still looking for: metadata enrichment, machine learning for data discovery, and then user study meta research. This is stuff that we still have on our agenda to do in the future. So if you're interested into any of this in particular, please join the group because we really want you to, you know, to get together more further. Yes. I would say that that's it. I feel almost bad for shaving up 9 minutes that I could have used to advertise the group a little bit more. But there's nothing more I can think of. So anyone has any more final questions, comments, compliments, I don't know, something. There's a chat. Yes, also, if you have ideas for new topics, please add them to the notes. We have a bit of capacity right now because we're just finishing up this this principles paper, and then we kind of looking for new topics, going in this direction of, you know, I would say trend detection and going like, okay, what's like the newest thing? Is of course something that we have been looking into. But I mean, it really lives with you guys. Like if we don't have any feedback, then we will doing probably the whole the same thing all over again. So please join. Please bring in new ideas, and please share what you are doing in your institutions with data discovery. And don't be how shall I say? We don't do stuff like this every day. Like most of us in the group are really just like you know, running their own repository and then occasionally fine-tuning their search a little bit, and not doing sophisticated research on technology that didn't even exist 2 years ago. This is I would say this is the peak of the iceberg. The actual iceberg is much more pedestrian and probably much closer to what you do every day as well. Okay, there's another comment by Graham. Thanks for this. I like this group tends to provide focal point for research. Yeah, so well, Graham, please join again for the next plenary. We're definitely going to Costa Rica. Because also, I mean, it's in Costa Rica, so why wouldn't I go? And looking forward to seeing some of you there, of course. And yeah, I think now we have 5 more minutes. Uwe, you have unmuted yourself. You want to say something?
No, I just got prepared.
Okay, you're just on the run. Okay, perfect. Gutes Mitfang. Anyone else want to have final words?
Thank you for moderating and sharing the session today, Brigitte.
Ah, yes. Thank you for having done it yesterday. I think that was very nice, and I wish I'd been able to replicate it more closely.
Thank
And
you
also,
for sharing today, and thanks for all the people coming along, and for Tianying and yeah, presenting this group. And happy to take 5 minutes back in life.
yeah, also, of course, thanks to Ming-Fang for preparing the slide and being just, you know, all around awesome, and, you know, really being the mother of the group in a way.
Oh my gosh. I feel old now.
Oh no, that's what I meant at all.
Just joking.
Yeah,
Okay.
yeah. And also, I just marvel at the fact that you just, you know, I mean, this is, I don't even want to know what time it is. Okay, then as everybody's already leaving, I'm closing the session. If you want to stay and chat for 4 minutes, then please go ahead. Otherwise, thank you for attending and have a nice rest of the RDA.
Hi, everyone.
Thank you.
Und du bist jetzt in Dresden?
Ich bin in Dresden. Ich gucke hier gerade raus aus diesem Hotel da neben dem Bahnhof. Guck von oben so runter. Ist ganz nett. Ja, ja. Nee, ich muss nachher noch NFT, ich muss nachher NFT for Earth, da muss ich noch was über Terminologien und erzählen, irgendwie, ja, ganz kurz nur, irgendwie 10 Minuten. Da zeige ich dann irgendwie das, was ich letztes Mal in der Gruppe hier gezeigt hatte, mit diesen Broader-Terms in die Suche mit reintun. Dass man halt dann irgendwie, was weiß ich, nach Schnecke suchen kann, aber dann auch irgendwie die einzelnen Arten findet oder, ja.
Ja, das hätte ich vielleicht als Beispiel bringen sollen, aber ich sage es dir echt, also also eine Vorlesung ist sehr viel einfacher, weil da habe ich ja meine Folien selbst gemacht.
Also.
Und ich habe jetzt zwar schon ein paar Mal über die Prinzipien vorgetragen, aber es ist immer wieder, dass ich da drauf gucke und denke so, warum ging es da noch gleich?
Ja, so. Nee, alles gut. Nee, aber jetzt regnet hier, nicht so schön. Wie ist es bei euch das
Wir
Wetter?
müssen mal das Recording hier stoppen.
Also, oh, Entschuldigung.